Okay, so if you remember from before, we are looking at minimal spanning trees, and there are two methods to find the minimal spanning tree: Prim's algorithm and Kruskal's algorithm. And right now we are looking at Kruskal's algorithm to find the minimal weights on each edge to connect all the nodes. So for step one with Kruskal's algorithm, you have to look through the network graph to find the lowest edge. Once you find this edge, you follow it and you connect it to your second vertex. So that means you'll have two vertices and one edge. Then you have to choose the next lowest edge and you connect this one. And so then you'll have an edge, three vertices, and you need to repeat this until all the vertices are connected. So now I'll show you what this algorithm means through sharing my whiteboard with you. So if I share my whiteboard with you, here we are, you can see I've drawn up a network graph. And we are going to use Kruskal's algorithm by finding the shortest weight to find the minimum spanning tree. So I'm going to do this in pink. Here we go. So I'm going to look by my eye and I can see that the shortest or the minimum weight on all of the edges is 5. So I'm going to go ahead and I'm going to connect E to D. So this is what the algorithm meant, because now I have two vertices and one edge. Next, you have to write down or keep a record of where you have gone. So I'm going to just do this, and I have gone from D to E. So D to E. Okay, next I am going to look and I'm going to find the next shortest weight on an edge. 7 is pretty close to 5, which means it might be the next minimum weighted edge, but here is 6. So 6 beats 7, so 6 is our next minimum weighted edge. So I have just gone from E to F, so I'm going to write down E to F. So you can keep a track of where you are going. Now I'm going to have a look, and the next minimum weight is this one, 7, which we saw before, from B to C. So I'm going to go ahead and I'm going to highlight that line, and I'm going to keep a track of where I'm going. And I just went from B, the vertex B, to the vertex C. So I'm going to write B to C. Now, next, we have a look and we have to see the next smallest or the lowest weighted edge. So there's 11 here, but 10 is here. So from B to A is the next minimum weighted edge. So we're going to do that one, and I'm going to keep a track of where we're going. We went from B to A. B, A. Now, the next minimum weighted edge is F to G, 11. So I'm going to go here and write that down and keep track of where we're going. F to G. And finally, we have got what looks like two separate spanning trees. We have one here, D, E, F, G, and one here, B, A, and C. And because we need to connect all edges to the nodes, we have to find the next smallest edge that connects these two spanning trees, which means 12, the edge from A to C, will not be an edge we are using because it would connect it to itself. And if we chose this edge, we would have two separate spanning trees that are not connected. And so that is not a valid edge. So instead, we have to choose an edge from DB, BF, or CG to connect these two spanning trees that we have created. And so the smallest weight on these three is 14. So I'm going to go ahead and I'm going to choose this edge here. And finally, I am going to write down FB so that I can keep track of where I have been. So that is Kruskal's algorithm. And what you have to do now is go ahead, use your calculator, and follow this algorithm that you have made here, D, E, E, F, etc., to come up with what the weight would equal. So it would be 5 plus 6 plus 14 plus 10 plus 7 and 11. And that would equal a total of 53. And so this minimum spanning tree we have created using Kruskal's algorithm equals 53.